if I make the sine diagram, and once again, we're starting at 0 and including that and going over to 2 pi. We have to put these on the number line in their correct order. Okay, so as I go around the circle, pi over 6 comes first, then pi over 4, then 2 pi over 3, then 3 pi over 4, then 7 pi over 6, then 5 pi over 4, then 5 pi over 3, and then 7 pi over 4. Okay, so above the pi over 4, etc., we got to put question marks because we don't know what's going on there. All right, because it's undefined there. And then above the pi over 6s and pi over 3s, we put zeros there because the function is 0. And now what we need to do is get in here and test what's going on. So we can start off, we can use 0 as a test value and plug it into the function. And I'm going to get a negative. But now we're looking at what's going on between pi over 6 and pi over 4. And there's no common angle in there to substitute into that. So once again, we can go back and think about unit circle stuff. If I'm looking at an x between pi over 6 and pi over 4, then if I want to know what 2x is doing, I can multiply everything by 3. Now, I've got an angle between pi over 3 and pi over 2. Tell me about its tangent. So, here's pi over 3. And the tangent of pi over 3 is radical 3. And here's pi over 2. The tangent of pi over 2 is undefined. So if I'm an angle whose terminal side is in here, then the sine is getting closer to 1, but the cosine is getting closer to 0. That means the tangent's increasing from radical 3 up to infinity. That means that the tangent in here is bigger than radical 3, so that when I subtract radical 3, I get a positive number. Now, between pi over 4 and pi over 3, you can actually plug in pi over 2. Tangent of 2 times pi over 2 is tangent of pi minus radical 3 is a negative. Okay, now if we want to pick something between 2 pi over 3 and 3 pi over 4, we're in the same position we were before. And there's no exact value in there, convenient exact value in there we can pick. So we can go back and think unit circle again. If I'm going to pick an x between 2 pi over 3 and 3 pi over 4, then what going into the tangent is the 2x. So that would be 4 pi over 3 is less than 2x is less than 3 pi over 2. So that's going to be an angle down in quadrant 3. And let's think about what's going on then, unit circle wise. There's the terminal side of 4 pi over 3. So I'm going to be an angle in here somewhere. Now I know that the tangent at 4 pi over 3 is radical 3 because in tangent 3 we have a positive tangent because the x and y coordinates are both negative. And as I move into 3 pi over 2, that's going to increase, which means that this is a positive number. And then you can continue between 3 pi over 4, 3 pi over 4 and 7 pi over 6, you can pick pi, and you'll get a negative out of that. Between 7 pi over 6 and 5 pi over 4, nothing really convenient in there, so you can go through the unit circle analysis and get a positive there. Between 5 pi over 4 and 5 pi over 3, you can pick 3 pi over 2, you get a negative. Do a unit circle analysis, it'll give you a positive there, and we can plug in 11 pi over 6 to get a negative there. Okay, so that's one way to get the sine diagram. Or you can take the time and think about what's happening graphically with this function. So if you were to graph tangent of 2x minus square root 3, the first thing to pick up on is that we have the tangent 2x as opposed to tangent x. That's going to make this thing go essentially twice as fast. So I'm going to just carve out some room here. So we know with the regular tangent, one cycle of the regular tangent looks like that. And it's between negative pi over 2 and pi over 2. Well, if I've got tangent 2x, then it's going to go between negative pi over 4 and pi over 4, and then it's just going to keep continuing like this. All the way down the line. This negative square root 3 here, that we're subtracting, is just going to pick this up and move it down. That's it. So if you just look at the pattern, it's negative, positive, asymptote, negative, positive, asymptote, negative, positive, etc., which tells you the sign diagram will alternate as well. And as we mentioned, sign diagrams don't always alternate, but in this case it does, and this is the graphical way to do it. So whether you go back and plug in values, appeal to the definition on the unit circle, or look at it graphically, there's your sign diagram for this function. So what's my final answer? So you go back to the original inequality, and I want to know where the tangent of 2x is greater than or equal to the square root of 3. That's equivalent to the tangent of 2x minus the square root of 3 is bigger than or equal to 0. So for my final answer, I need to know where the f of x is bigger than or equal to 0. And so where's that going to be? Well, it's bigger than 0 from pi over 6 to pi over 4, and then again from 2 pi over 3 to 3 pi over 4, and then again from 7 pi over 6 to 5 pi over 4, and then again from 5 pi over 3 to 7 pi over 4. Okay, so pi over 6 to pi over 4, 2 pi over 3 to 3 pi over 4, 7 pi over 6 to 5 pi over 4, 5 pi over 3 to 7 pi over 4. I'm allowing it to be equal to 0. It's equal to 0 at pi over 6, 2 pi over 3, 7 pi over 6, and 5 pi over 3. It's undefined at these other points, so I'm going to have a parenthesis at each of those, and then I'll connect them up, doing the union thing. So my final answer is including pi over 6 up to but excluding pi over 4, including 2 pi over 3 up to but excluding 3 pi over 4, including 7 pi over 6 up to but not including 5 pi over 4, and then including 5 pi over 3 up to but not including 7 pi